All right, everybody shut up. Extra credit opportunity tonight. It's worth one free homework assignment or quiz. We have at 7 p.m. tonight. Grace Ice Cream Social. It's in 109 across the hall. So this is the computer science group, women in computer science, but everybody is invited. Men can be members of this group. It just happens to be a women's chapter. Free ice cream. And I think they were playing charades or something, or I don't know, combat twister. I'm not sure what we're playing, but we're playing some games. 7 o'clock in the old fishbowl, so 109 across the hall here. I'll have a sign-up sheet, so if you're there, I will. You can sign in the sheet, and if you bomb a quiz or you get a 0 in a homework assignment or something like that, or you don't get 100% in a homework assignment, this will boost that to a free 100. So I'll keep a list of tokens. Tokens of extra credit that you will accumulate during the semester, and at the end I will go through and distribute tokens in the lowest grade places to bump your score. Sound good? Mm-hmm. So you're not penalized if you don't go. Just don't do poorly in homework assignments.
I would go, but I have a class.
You have a class at 7 o'clock?
Mm-hmm. It goes from like 5 something to 8:20.
That works.
Jeez.
I go from 6 to 9.
Believe me, I don't like it either.
What class is it?
History. Steelers. Oh my god.
Well, if you guys take a break, if you take a break in your class and you run down there and grab some ice cream or something like that, you can sign in.
Does that count too?
But you actually have to physically get there. So you have to use your 10-minute bathroom break to come to the Grace event between 7 and 8 p.m.
Sure.
And I'll count it.
He purposely left the door open just
I'll be
to yell
there.
at people that pass by.
I know.
All right, questions about that?
I won't be there.
That's fine. I'll find out on the sheet. So you're not being penalized if you don't, but you get a, what is it, like a get out of jail free card or something like that if you have we get ice cream. Yeah.
That's the most important thing.
Yeah, you do get ice cream. So I've been told it's 0 calories, 0 fat.
Ice cream?
Yeah, I'm lying. Interesting technology news related to sports, actually. Kind of an interesting thing. I'm assuming most of you in here do not watch golf. Does anybody in here watch golf? Okay, do you know who won the playoff event yesterday?
No.
Okay, so we're in the FedEx Cup playoffs right now in golf, and the guy who's won the first 2 events is this guy named Bryson D Shambo, and he was the NCAA champion 2 years ago. But forget about the golf side of things. The guy is he's a scientist, so he has his degree in physics and mathematics, and he applies that to golf. I mean, earlier this year, there was like a rules violation. He had a compass on the course, but not like a compass north, south, east, west. I'm talking about the thing that used to like draw circles and calculate angles and stuff like that, because he didn't believe that the pin placements that they had on the sheets they handed out to the players were completely accurate. I mean, this guy is like he's measuring like degrees of angles on the course like during play. And he's good. And he even plays golf weird. Like his, I actually play with the same clubs he uses. He uses these. If you're a golfer, the clubs are different lengths. So like an 8-iron is a shorter club than a 4-iron. Well, he plays with all same length clubs. And I play with them as well, but I do it for my back. So all my clubs are the length of a 6-iron so that I don't have to like lean over so much for like sand wedges and things like that. Well, he plays that way, and he has this like mechanical, like weird swing that he's like created through physics. Okay, so he hits the ball a mile, and he's very accurate, but it's just weird. Okay, but it's all based on science. So he's like applying science to golf, and it's kind of fascinating to watch it when they interview him, like after the events. I mean, he's like ultimate geek. I mean, he's sitting there in the interview talking about the gravity at this longitude. And he's like, huh? His name is Bryson D Shambo. DECHAMBOU. Blah, 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 blah. Yeah. Huh? Well, he engineered the rest of the club to have the right swing weight. So on a sand wedge, all of a sudden the shaft, instead of being a shorter shaft, is now the length of a 6-iron. So what he did is since he added weight there, he took weight away from the head. So he's out there like drilling holes in his clubs. I just find it very. I mean, I'm a golf fan anyway, so I find it fascinating that you have this guy that is just applying like a ridiculous amount of science to his profession, to the point where, like, I mean, during practice rounds, he's literally out there measuring the slope of, like, a little bump in the middle of a fairway. Okay, I mean, this is like a 7,500 yard course, and he's out there measuring individual little hills, like not big hills, like, well, I'm going to plan on hitting my drive right here to this spot. Therefore, my feet are going to be standing on this slight 2.8 degree downward angle. And what's really funny is when you can listen to him talking to his caddy during the round, they're talking in the same language. I mean, he's like, this is a 5-degree downslope, so I'm actually going to move my thumb here, and I'm going to play this at 0.2 degrees out to the right. It's pretty fun. It's kind of amazing to watch, because it almost sounds like it's a joke, but it's not. Yeah, at some point go on YouTube maybe and I think they call him the mechanic, they call him the mad scientist, he has several different nicknames. But he's a really nice guy. And he's playing pretty well. He's won 2 events in a row, and these are the events with the top. Last week was 125 players in the world, and this week was the top 100 in the world. And he won both of them handily. So, I don't know. All right, so questions about the Grace event tonight, 7 p.m. Yes?
How long does it go for?
I think it's scheduled for an hour. If you have to leave a little early, it's not the end of the world. But if you can get there at 7, that would be best. That way you can learn about when meetings are going to be, what the group is all about, because there's going to be other opportunities like this. I want to encourage attendance at these Grace events. So, yeah, what?
If I just come there, sign, and then go back to my class, does that count too, or no?
Well, it'll count, but you have to have ice cream. Actually, I don't care if you have ice cream, but you can't just pop in the door, sign, and pop out. You have to go and say hi to people or something. There's got to be a minimum of 3 minutes. 3 minutes that you're in the room, saying hi and shaking hands. You're going to be there, right?
Should be.
Yeah.
I think I can.
You go say hi to Blaine. Mr. Gonzalez will probably be there.
Sure. I'll be desperate.
He loves ice cream. He loves ice cream. He loves alcohol. Okay. So everybody's clear on the thing tonight? If you don't come to it, you're not being penalized. This is just a get out of jail free card. If you plan on not missing points on quizzes and homework, this will not benefit you at all. Makes sense? But if you miss a quiz or don't quite get full credit on a homework assignment, this will benefit you. All right, so last time we were talking about variables. I did mention we got Eclipse downloaded last time, and I at least got it open. I think I got it open. Has everybody gotten Eclipse on a computer to some extent at this point? Okay, so eclipse.org. I'm using Photon in here, which is the newest, latest, greatest, blah, blah, blah. If you have an older version, it'll work just fine. I'd probably encourage you to get the newest, but whatever. Go ahead.
I'm still getting my computer pop up as an error. I tried reinstalling Java, and one was still giving me
And you've uninstalled and then reinstalled from scratch?
Yeah.
I don't know. try it. I assume you Googled the error?
Yeah. And it's just like stuff I don't understand.
Okay. I'll have to take a look at it. So we'll have to have you mess with it. But if you can't get it to work out, message me and then we can sit down and try to figure it out. Yeah.
Where did you, wasn't there a link to it?
I think I have a link on the. I think it's on Blackboard, but it's eclipse.org. This guy right here, and then I think you go to projects. Is it projects? Yeah. See, I give you a link directly to the thing. Let me go back here. Maybe I got to click on Eclipse Photon, so learn more. But I give you a link directly to the download for it because I specifically want you to get the one for. Let's go other package downloads. Yeah, Eclipse IDE for Java developers. This guy right here. And then you want to download the version for your platform. One thing you might try is, are you getting the 64-bit version?
Yeah.
You might try the 32, just see if it makes a difference.
Okay.
Just, definition of insanity. Yeah, but if you go to Blackboard, there's a link directly to like the Eclipse IDE. Otherwise, this is the guy you want right here, the Eclipse IDE for Java developers. And make sure you look at the entire phrase here because there's other ones that have the word Java in it. You want the one specifically for Java developers. Got it? Okay, so once you have that installed, when you first open it up, it'll ask you where do you want to store your stuff. You can pick wherever you want to store your stuff. One thing that I recommend everybody use, I'm going to actually bounce back here for a second. How many of you in here use Dropbox or something similar to Dropbox? So cloud storage. Now I can't speak for sure, but Google Drive used to have problems with some IDEs because it would store files that had a weird file name, but I'm not sure if Eclipse is one of those. But things like, I'm a big fan of Dropbox. Dropbox gives you, I think, 2 gigabytes of free storage as a student. I think there's ways to get it bumped up to even more if you share it with people or something like that. So Dropbox.com, Google Drive. What's Microsoft's called? Microsoft Web Drive. Is it Web Drive? OneDrive. Microsoft OneDrive. Things like that, where you effectively have a folder on your computer and anything you put in that folder automatically gets saved to the cloud. I'd recommend all of you use something like that. And then when you go to Eclipse, choose that workspace as your, choose that folder as where you're going to store your workspace. That way, whenever you're working on stuff and you save it, it'll automatically get pushed to the cloud. So if your machine, you lose your computer, it dies, whatever it is, you haven't lost your stuff. Make sense? So good IT practice. That way you don't have to spend time worrying about backing up your stuff. It automatically backs itself up just by putting it in that one directory. All right. So I've used Dropbox for years, so I highly recommend that. The other ones are very popular as well, but I can't necessarily speak to whether you'll have issues with source code or something like that. I'm confident you'll probably be fine with them, but I know in the past Google Drive's had some issues, I think with Xcode, kind of strangely named files or something like that, and it didn't like those naming conventions. So just heads up. I'm going to just choose a random workspace on here, but just whatever. All right, so Eclipse will open up and we'll look at this some today as we talk about variables here in a few minutes. But when Eclipse launches, it'll look like this. You can go ahead and probably just close this welcome thing up here. And this is kind of what the thing looks like. You have this package explorer over here on the left. This is where your code will live here on the right. All this stuff here on the farther right, you can actually minimize. We won't be using it in here. That way you have a nice big area for your code. And then down here is where you'll see your stuff run. All right, so when you first get started here, I'm just going to start a project that we're going to use for some of our sample stuff. I'll go to File, New. I'm going to choose Java Project. Project name, I'll choose CSC250. Let's just call it Starter. All right, it wants to know what execution environment you want to use. On this machine, I have the newest Java installed, so it automatically found it, but you can choose other ones that it's found on the machine, but more than likely you'll just use whatever the default is in there, and then don't make any other changes. Just go ahead and hit finish, and that will create your project for you. I don't discourage module names. By convention, modules start with a lowercase letter. Oh, he didn't like that I named my thing that thing, but I'm gonna just say create anyways. I think it's fine. All right, let me get this font a little bit bigger here. I would have thought that would have been inside of Java Editor. Where do I change my font? Colors and fonts. Is that big enough? Is that too big? About right? All right. Okay. Actually, this is a very interesting setup here, this module info thing. I'm gonna close that. So I'm not gonna worry about this module info thing. That's something new with the new version of Photon. So I'm gonna go to my source folder. So once you create a project looks like this, gives you a little folder. And this JRE system, you don't have to worry about that. That's the Java runtime environment. So that's where it's gonna launch. That's how it's gonna launch your program inside the Java virtual machine. Then it gives you this little folder called source. That's where your actual source code will live. Right click on that, say new Java class. All right, and I like to name this class driver. That'll make sense kind of later on, but for right now, the class that'll have our main method in it we'll usually call driver. Hit finish. It's going to give you something that looks like this. And then usually we write our standard hello world program. So public static void main string array args system.out.println hello world. All right. Then you hit play. Is this the module crap? Unnamed package not allowed in the module. I'm going to delete this module thing. I'm not so cool with this. Maybe I made a bad decision by choosing to create module. Maybe I should have said don't create. Yeah. So if you went ahead and you did the create module thing like I did, just delete that file. Maybe in the future, just say don't create. This module thing is something new with Photon. I don't know what the deal is with that. But in any case, in source, it went ahead and created this thing called default package. And then I have my driver.java inside of there. Looks like this. When you hit play, it says hello world down here. I don't know if I can change the font in this guy. Maybe not. We'll just roll with it. All right, so that's your working Hello World program. Now, one thing I'd highly encourage you to do, and it might benefit you on a quiz sometime. I'll go ahead and copy this. Let's see, where's Slack? I'll go into 250 on Slack, and I will post a code snippet. Say hello world. All right, so it's up there on Slack in the 250 group. You should be able to write a hello world program in Java, 100% accurate when you sit down starting by next class. Okay? It's not so much that I want you to be able to write hello world. It has a lot more to do with the fact that 100% of your Java programs will start this way, with the exception of this one line. And the thing we're allowed to change here is this dude right here. I can call this elephant or something like that if I want. And we'll talk a little bit about that as we get into this. But this is going to say, how do I want to save and launch it? I'm just going to say always save resources before launching because I didn't actually save. So I'll just select that so it doesn't scream at me again. And okay, there's my hello world. All right, so you should be able to write a completely error-free hello world program by next class. So that means it needs to have public class. You can name your class whatever you want. So I just happen to name this thing driver since it's the file that drives my program. We're going to be using this for a while. Okay, but in order to have a working program, you have to have a class. We'll talk about that today. And then inside that, you have your main method. All programs begin and end with main, and the main method in Java must look like this. Public, static, void, main. It's going to take a string array as a parameter. You can name that parameter whatever you want. So the default typically is args, because this is how you take in command line arguments, and I'll show that to you here in a little while as we kind of deconstruct this. But this guy can change, but I would just encourage you to memorize it as just args. Okay, opening, closing curly brace, and then system.out.println hello world. Make sense? No errors. So make sure you don't forget any semicolons. Make sure you don't forget opening and closing curly braces. Make sure the S is capitalized here. Okay. The whole reason for that is so now once you have that memorized, if you sit down in front of a text editor that won't generate this stuff for you, you can give yourself a working starting point for any Java program. Make sense? All right. So I'm not going to spend a whole lot of time having you memorize all these different things in code. This is just one of those things that would be beneficial for you to have as just a go-to move. All right. So do you have a hello world program working in Eclipse, and when you hit play, you get hello world down here, then you know that your Eclipse is set up fine. All right, so let's go back here and let's talk about variables. All right, so last time we talked about primitive types. Before that, we talked about there are two different types of types, which is a funny slide. Today we have primitive types and we have object types. What are primitive types? What's the definition of a primitive type?
It can hold a value.
Okay. Oh, built into the language, it can only hold a value. That's the extent of its talents. Where object types can potentially do more. And we haven't dealt with object types yet, but trust me when I say they can potentially do more. Okay. Last time we looked at the details of primitive types. Okay, I don't expect you to memorize this stuff, but these first four here, byte, short, int, long, you have four different primitive types that are all capable of holding signed whole numbers. What does it mean for a number to be signed? Okay, so it's capable of holding positive and negative numbers. Now, how much does it cost it to hold positive and negative numbers? What's the downside of a value being able to hold positive and negative numbers? Notice here when go ahead.
Take some space.
Take some space. In this case, 1 bit, right? So byte, short, int, long, these guys are all signed numbers. So a byte is 8 bits big, but it can only hold values in the range of positive or negative 2 to the 7th power, because one of those bits is used for the sign. 16 bits, plus or minus 2 to the 15th power. 32 bits, plus or minus 2 to the 31st power. 2 to the 63rd power, so on and so forth. Make sense? Okay. One of those bits is used for the sign. In 325, you'll learn how it's used for the sign. It's done with something called 2's complement. But for us in here, just know that we've lost 1 bit for holding the magnitude of a value to keep track of a signed value. Not the end of the world, but it's still a thing. Got it? Okay. Why do we have so many different ways of holding whole signed integers? Why do I need to have bytes, shorts, ints, and longs? Why do I need to have 4 different ways of holding signed whole integers? Go ahead.
Memory used to be expensive.
Okay, memory was expensive, so we used to have these tools in our granular, and I mean, these guys came from an old language like C. So we needed these tools to, as a programmer, to be really granular about how much memory we were going to use to hold one of our variables, because we would not want to hold the number 7 inside of a long, because we would then be taking up 64 bits of memory when we actually only needed 8 bits to hold that value. Okay, now we don't care. So now most of the time we're going to use an int. If that's not big enough, we'll use a long. If that's not big enough, we'll probably move over to some object type like big integer that's built into Java. When will we use bytes? So I mentioned that we would never see a short today, but I said you might still see bytes. When would you see bytes?
For something convenient that could be directly held by a byte.
Okay, for example?
Like the same size as a byte.
For example? I think I gave an example when I mentioned this. Yeah.
It was for streaming.
Yeah, like video streaming.
Oh, right.
So something we do fairly often is video streaming type stuff, right? And it just so happens that when you're doing video streaming, typically things stream in 1 byte chunks. So it just happens to be the package size that you're receiving, so you might as well throw it into something that was built custom made for it. So it has nothing to do with the amount of memory, it just has to do that it's the right fit. Shorts are relatively bad. Now, actually, we do see shorts as maybe coming back into vogue just a little bit, because some of our new streaming technologies, specifically for 4K, are actually moving up to a 16-bit package for streaming. They're at least playing with it, so but whatever. All right, so that's why we have these guys around. These all came from C, so that's back to this slide way up here that shows our lineage. So even though we're looking at a language right here with Java, we still have the primitives from C++, we still have the primitives from C. Okay, so these are leftover kind of relics from the older languages, and they're still applicable today. But most of the time, we'll use ints. Okay, now chars, these guys are unsigned whole numbers. So these are 16-bit values, but they're unsigned. So that means they get to hold the entire value space for 2 to the 16th power. So that's 0 to 65,535. Okay, what's Unicode?
Universal code.
What is it? That's what it stands for. What is it? What do we use it for?
Don't remember.
Yeah, I would encourage you to always know the name of acronyms and just not know anything about what they do.
Obvious.
Yeah, it's a great. I would actually go the other direction where it's kind of meaningless to know what something stands for as long as you know what it means, like what it's for. So, go ahead.
It's kind of like ASCII, except okay, I suppose. So it's like universal.
Well, maybe Sam can help you with what ASCII stands for.
It's the universal
Yeah, I
sound.
might as well just drop out of this class.
Well, no, wait, do you got what ASCII stands for?
I forgot.
American Standard
Oh,
Code.
I know.
What's the rest?
American Standard.
Well, she already said the code part. I mean, you're supposed to improve upon where she's got American Standard Code. I forgot the rest of the part. Then you're like American Standard.
I got American.
You got American? American Standard Code for information interchange. Again, relatively unimportant. some point.
It's
Well,
like
actually, I say relatively unimportant. There's always a risk at our CS get-together each semester that Dr. Locklear might put one of those questions up there on the slides where you have to know what ASCII stands for or something like that. And whatever it is. Okay. So I'm not saying that knowing what acronyms stand for is unimportant. I just think it's significantly more important to know what it means, what the impact of that technology is, as opposed to what it actually stands for. All right, so we've covered that. Okay, so you said it's kind of like ASCII. How's it kind of like ASCII?
It's like the characters that, or the okay, so the characters of the alphabet and other random symbols are assigned to different numbers.
Okay.
Like 10 would be mapped to, or no, not.
Whatever it is.
A would be mapped to 10.
For example, that's not the actual mapping, but yeah, whatever it is, it's mapped to something.
Right.
What's the purpose of the mapping? Why do we waste our time doing the mapping thingy?
I know that like hexadecimal.
Go ahead.
Because you just can only work in numbers. So if we want to use, let's say, emojis, you just can't speak emojis if you use numbers to represent those.
Okay. Now the reality is, you said computers can only work in numbers. That's probably mostly true. We build computers to operate in zeros and ones because that's where it's most efficient. That's digital logic. I mean, if we really, really wanted to, we could put a emoji chip inside of a computer that instead of using a lookup table, it legitimately just knows emojis. Hey, look, that is not that far-fetched, because I think I told you this last semester, but this language over here, Swift, you can name variables with emojis. It is ridiculous.
What's the whole point? Do we have to learn Swift?
No, you don't have to use emoji. You just can. You know, it's kind of like one of those things, like the newest, latest, greatest smartphone comes out, and they have some feature in it that you like I would never use that, but you can. Okay, like the one that comes to mind, and this is like less emoji. It's like the old Galaxy. I think it was like the S6 commercials where they had all the people waiting in the line for the iPhone, and they had the two Galaxy people walk up, and they wanted to swap playlists. So like they bumped, their phones together to swap playlists. Have any of you ever used that feature?
Yeah, at work we used to do that for transferring contacts over at Walmart for new phone upgrades. We did do that.
Okay, so you found it to be useful.
It worked no different than Bluetooth, but we did it just because we could.
Yeah, but just the commercial really emphasized this idea that you creating a playlist and then wanting to share it with other people was like a daily occurrence. Like that was going to be your decision-making thing, like buying the phone. Because they, notice they didn't talk anything about the battery life, because that was back when Android still had battery life issues. It's like, what are you wearing that giant backpack for? Well, I have 2 car batteries in here. I get 3 hours of battery life with this bad boy. Not an issue anymore. In fact, man, this is the Note 9 that has the crazy battery that's probably going to explode at some point. So this has a 4,000 milliamp battery. I didn't have this thing plugged in at all yesterday. I was just like vegging on the couch watching this golf like all day long, and then I watched movies after that. I was like 23% battery at the end of the day, but I was just using this thing constantly. So I'm pretty impressed with the battery life on it. So I was downloading torrents on it.
When I used to download and watch anything on it, it drained the battery.
Yeah, but now you just get a giant battery. Now I'm just waiting for it to explode in my hand and take fingers off.
That would not be
Still have
fun.
like a lower chance than like getting struck by lightning though. That's the thing. But like because
Like, what are you basing that on? Isn't there some like statistic like 99% of all statistics are made up? Like, I think that's a true statistic. I think I've heard that at some point.
I read like an article that like percentage wise of people who had like the Note like 3 or whatever I think it was.
The one that was exploding,
Yeah.
the Note 7, the 2 ago, yeah.
Like of the people who had those phones, like the percentage of that actually happening was so low.
I see.
And then like compared that to like all the people in the world getting struck by lightning, it was like a lower number than that.
Oh, I see. Look, that's possible.
How many times did it actually happen?
Oh, several.
Enough.
But there was also a lot of people that had the phone.
It was like highly publicized though, but you don't like publicize. You know, some guy got struck by lightning.
But I travel quite a bit, and they specifically signaled out the Note 7 at the time on airplanes, making you completely turn it off.
Oh yeah.
Yeah. It's like, you know, they tell you to put your normal phone like airplane mode. You're in Note 7, that thing needs to be off the plane. They would let you bring it on there if you had it completely powered down. But in any case, Swift allows you to name variables with emojis. It's kind of a funny thing. Yeah, but in any case, we have this mapping because, as he pointed out, computers like numbers. Computers really, really, really like numbers. And we're very good at storing numbers in computers. And if we can store bytes and shorts and ints and longs and chars all the same way as just numeric values, that's perfect. Something we talk about in 325 is going to be make the common case fast. So if we can make the common case in our computer architecture really good at storing numbers, then we might as well leverage that and then come up with other ways of mapping in the events that we do need to do the mapping. Okay. Now you mentioned that ASCII is kind of like Unicode. How do those two relate? So it's a lookup table. That is, you store the number, and that number then during runtime, since it's flagged as either it's flagged as a char, that gets then mapped over to the character representation of that number. But how do ASCII and Unicode relate? What's the difference between those two?
Unicode is bigger than ASCII.
Unicode is bigger than ASCII, so it's newer than ASCII. Yeah, it came out significantly after ASCII. The first 256 characters of Unicode are the ASCII character set. So Unicode is a superset of ASCII because at some point they decided, you know what, there's other languages in the world than just English. And we only use, 26 characters for the lowercase, 26 characters for the uppercase, then what, maybe 12 or 13 for punctuation stuff. And that was it. And then the rest of it's smiley faces and playing cards in ASCII. But Unicode gives us access to symbols from all sorts of different languages and that kind of stuff. Okay, so a char doesn't need to be unsigned, because we have, in this case, since Java supports Unicode, we have 65,536 unique symbols that we support. That is 2 to the 16th power, which will give you a 0 to 65,535 as a possible values. So that means you can look up, the character that lives that bucket 65,530, and that's going to map to some character in some language. Okay. All right. And then floats and doubles, these guys can hold decimal point values. So these are kind of like ints and longs in terms of one being a little bit bigger than another. Go ahead.
Well, updates like the official Unicode, like currently the standard.
I would assume IEEE, but I guess I'm not sure. I don't know if it's an updatable thing. I think Unicode is. So I mean, I think of if a new language came out, like a new human natural language, and they petitioned that it was important enough to get put into something, I think you need to have something that was a superset of Unicode. Yeah, maybe it's galactic code. We need something bigger than Unicode. Galactic code. Or Elasticode. Maybe they do that. They do Elasticode and then say, okay, we're just going to make this 256-bit just in case. And then you have 2 to the 256 power, which is a big number. It's a big number. Go ahead.
There's actually a subset built into Unicode that's empty. So
there's room for growth?
Yeah, there's like 2,048 characters and you can put whatever you want in there. It's really hard to work with.
But it would need to be, so it's okay. So you're saying it's a open area that an end programmer can leverage.
Correct.
Not necessarily something that you can petition somebody to throw, hey, I want my new made up, or get Klingon in there or something.
You could put that in there, but it needs to have something on if you're using Microsoft. It has to have a Microsoft language pack built in.
Like a resource file that it reads from to give semantics to it.
Write scripts that recognize.
Yeah. Yeah, but I mean, Unicode is so what he's saying makes sense, that there's buckets that aren't currently used, but Unicode's an existing language, so it'd be the programmer who would add that stuff in for their own purposes, as opposed to, if some new nation, some country split and they decide to come up with their own language and they wanted to petition to get that in there. I would assume they'd probably have to create another superset character set or something like that. That's Unicode up to a point, and maybe they make it 17 bits. 17 bits doesn't make a lot of sense. They probably make it 24 bits or 32 bits, keep it as a power of 2, and then they just have more empty space. Booleans, just trues and falses. It used to be zeros and ones. We used to be able to do math with them. We can't anymore. We can't in Java. Java doesn't let you do math with Booleans, but you still can in like C and C++. It wouldn't make a whole lot of sense to do math with Booleans. It just so happened that you used to be able to do it as almost like a parlor trick. Okay, so variables. This goes back to our first slide. How do human beings solve problems? Memory, asking questions, repetition. 100% of programming languages have facilities for those 3 things. Memory is done through variables. Asking questions is done through conditionals. Repetition is done through loops and functions. All right, so first question we might say if we're learning a brand new language like Java is, how do you define a variable? How do we mimic memory in that language? So Java, being a strongly typed language, requires us to provide the type. So syntax for a variable is type, followed by var name, followed by, well, this part's optional. So if I'm writing this in like the official syntax, I would say equals value, then semicolon. So the stuff in the square brackets here is optional. The square brackets are not part of the syntax. So for example, you can say int a is equal to 5. You could also say int a and then put a semicolon there. And then at a later point in time, you could say is equal to 5 if you wanted to. You can assign it the value of 5.
Well, that means it's a common variable.
Right there, int. Int.
Okay, but
here you're using it. You're defining a variable named a here. You're defining a variable named a here. You're using a variable named a here, not defining it.
Okay.
So when you define a variable, you have to provide the type. So the type here is int. And this type can be anything that we can create types of. Right now, we've only learned about the primitive type. So byte, short, int, long, char, float, double, boolean. Now, we also have object types that are built into the language. Pretty quickly here, we're going to be looking at strings, but we can also create our own object type. So the thing that we put here in the type field can literally be an infinite number of things. Actually, technically, literally infinite is not actually accurate. I wonder what the longest variable name you can create. It's probably, I don't know if it's limited like that. Might be length of string. But if we assume it's 256 characters, which is a plausible assumption, that means you can have 2 to the, no, not 2. You would have each character can be any one of 20, well, it can be upper or lowercase. So each character can, and then you can have underscores and stuff in there too. So let's just say there's 70 possible characters that are part of variable names. So it'd be 70 to the 256 power is the unique number of variables. Yeah, but it's not infinite. It is a lot, but it is not infinite. And how many of those are, because one of the things that we want to do is we want to make sure we have variable names that are meaningful. When you create a place to store something that you want to remember for, for later, you want the name of it to be representative of the value you're trying to remember. Okay, so in this case, you probably don't want to name your variable some just random, string of 256 characters.
How long would that take?
How long would it take to do what? A long time. So we'd have to randomly generate it. It's almost like how many of you are using a computer that has the built into the web browser for when you go to a website, it'll generate a password for you. It just gives you a password that you would never want to type yourself, right? Like,
Never did that.
but have you seen it before? When it like pops up and you're registering and it says choose a password and it comes up with like this hexadecimal 128-bit password like, and then what do? You just put in your normal password, which is password. You probably do the.
I do that. Oh,
Yeah.
The funny thing is you'll probably be the first one to have their identity stolen. You take all these precautions, and then he makes one little mistake, like swiping his credit card at the Dairy Queen. And now somebody has a picture of your card, and they're going on an Amazon shopping spree.
Showed up with
They still need
video.
the back
Security
security
camera.
tunnel before it?
All right. So how do we create memory? How do we create variables in this language? It's the type followed by the variable name, optionally equals value. Now, most of the time, you'll probably give it an initial value. So I say this is optional, but most of the time you'll do it. And statements in Java always end in a semicolon. Okay? So this is how we define variables in Java. So if I bounce back over to Eclipse here, and we mess with this a little bit, I can come in here and I can say int a is equal to 5. Now, this is how we print stuff in Java. I'm going to go deeper into this at some point, but for right now, just if you want to display something on the screen, you say system.out.println, and then in parentheses after it, what you want to display. All right. So, and the system has to be a capital S, and the out is all lowercase, and println starts with a lowercase p. All right. And I'm just going to say I want to print out the value of a, which should give me a 5. So there's my tiny, tiny 5. There's got to be a way of making a larger font down here, isn't it? Should just assign it as a homework assignment.
I know. Yes.
Extra credit, get more font. Get more font. Write an 8 to 12 page paper on increasing font size. And I don't want to spend too much time on this, but I kind of want it to be a thing. Because it's going to be on console. Can I do it? No. Oh, well. If somebody figures it out at some point, let me know. All right, so I printed out the value of A, gave me a 5 down here. What did it do here? A is a variable, so it had to resolve that variable at runtime. So it went through, it figured out, here is something that is a variable name. Now, that's something we want to unpack a little bit. How do we know that this is a variable name? What are the possible things that can go inside of this opening and closing parenthesis here? We're going to operate off of our primitive types for right now. Well, we know that an int looks like a number, right? So something like 23. That's what an int looks like, okay? No symbols around it or anything like that. It's just numbers, numeric types. So we probably cannot create variables that start with a number. They could have a number in them, but they can't start with a number because that might get accidentally flagged as being an integer type. Okay, so that's going to drive one of the rules for our variable naming conventions. So integers start with a number as well as only contain numbers. Chars. Okay, now we might say, well, a char is a character like an A or a B or a C, but how do we differentiate the character A from a variable named A? Characters use single quotes surrounding them. All right, so we know that something is a char type if it has a single quote around it. So notice here, when I say system.out.println A, it's printing out a 5 because it's resolving this A. But if I put single quotes around this A, that's the only thing I change, and then I hit play, it'll print out an A. because no longer is it flagged as a variable that it has to go and look up the value for. Now it's saying, this is a char. Why? Because you started it with a single quote. So now it's flagged as a character type. Okay. Boolean is a true or false. So you cannot use true or false as your variable names. Okay, these things would fall into the category of something called a reserved word. All right, so we can't say int true is equal to 5. So notice I hover over this. The left-hand side of an assignment must be a variable. So it's flagging this true as a reserved word, not a fan of it. Okay. Similarly, other reserved words you can't use. You can't say if. That's a reserved word. You can't say for. You can't say while. Anything that's built into the language as a reserved word, you can't use as your variable names. All right. So, and Java will be happy to scream at you. So you don't have to go and memorize that. If you just pick a variable name that happens to be a reserved word, it'll scream at you, and then just change it to something else that's still meaningful. Okay, so it can detect whether something is a char by looking for the single quotes before it. Okay, Boolean, we would call these guys actually literal types. Okay, so a Boolean literal is a true or a false. It's like a solid value. There's no resolution needed. Okay, true is not a variable name. True is a value. It's a literal value. Just like the number 2 is literal. Number 23 is a literal value 23. It doesn't require any resolution. String, even though it's not one of our primitive types, in Java it might as well be one of our primitive types. Java is what I refer to as a string-based language. If you can get something into the format of a string in Java, you can pretty much do anything you want with it. Okay, strings are very malleable in Java. So string type, that's going to be double quote, stuff, double quote, 0 or more stuffs in there. So you don't have to have anything inside of a string. You can have the empty string like that. Okay. All right. So there's the string A. If I print this out, it will actually look the same as my output, but I'm actually outputting the string that is A, not the character that is A. Whatever. Punchline is, it didn't resolve it as a variable. I have a variable up here named A, and if I want to get the value of that, I don't put single quotes or double quotes around it. And now it will flag it as that guy must be a variable type. How do I know? Well, it doesn't start with a number, so it's not a numeric type. It doesn't start with a single quote, so it's not a char type. It's not one of my reserved words. And it doesn't start with a double quote, so it's not a string type. Therefore, it's either made up syntax error or it's a variable type. In this case, it checks to see, have you defined a variable named A? I have. So what it'll do at runtime is it will resolve this variable. And when I say variable resolution, just go after this one. Variable resolution. So resolving a variable means looking up the value that a variable contains in memory and ultimately boiling down to that value. Okay, looking up the value that a variable contains in memory and ultimately boiling down to that value. Oh, sorry. And remember, I have these slides linked on the on Blackboard as well. So at any point in time, you can go and get the current version of these slides. I mean, feel free to take notes, but it's just as a heads up. You don't have to mark down every little thing I write if you want to relax, participate, learn what Unicode and ASCII things like that are used for.
Obviously.
You know, Sam, maybe you should sit closer one of these days. Should I be taking it as a sign that students who sat in the front last year have now moved farther back in the outside of the splash zone?
You are very loud, so.
She told me that last time. She said last class I have a really loud laugh. I actually have the volume turned down. This is like at a 3. It goes all the way up to a 47. You guys could have probably heard me out in the hall today at the hymn sing. I was belting it out.
Turn up the stream mic a little bit.
Yeah, see, I'm practicing liking music.
Gotcha.
Yeah, it's not working yet, but
Okay.
I hate it
I
less.
was kind of curious about that when I saw it. I was like, he's coming a lot.
Yeah, I'm practicing. Plus, Pastor Smith, like, even though they list it somewhere, they don't make it convenient. It's like they sneak it in, they sneak it on you, right? Like, you show up and all of a sudden it's like, oh, we're singing hymns all day.
Oh.
What? And you're in the front row and you can't, like, like, can you really bail like mid-song?
Do you want a copy of the chapel schedule?
I can look it up.
Okay.
Yeah, I'm just too lazy to. It's fine. And
Okay.
I actually had morning today.
Okay.
Yeah, Dr. Locklear told me, but I just like invited my entire morning class to like come and sit in the front row with me. Obviously, they all showed up, as you saw.
I did.
Yeah.
Oh, they're
There was actually a couple people from that class that did come to chapel. They just didn't go to the front row. But I can't like invite a whole class to show up and then like not go myself, right? It's like poor form. Like I'm sure tonight my wife's gonna like give me a hard time about going to this ice cream social thing, but I mean I'll be there. So maybe I'll try the new motherboard tonight.
There you go. Yeah.
I'm afraid to try it.
Don't short it out again.
Is that what happened last time?
No, who knows? So we're building this supercomputer in the department for video and 3D modeling, rendering, and stuff like that. So it is a 96 core AMD EPYC dual CPU setup with 2 1080 Ti GPUs and what do we have? 128 gigs of RAM. RAM is relatively unimportant there. And there's only one company that makes a dual CPU board. It's a company called Supermicro. We are on our 6th board. None of them have worked. We have swapped out the CPUs, the power supply, the RAM, everything. And we can't even get a VGA output. So like in my mind, I'm thinking, because it's the only company that makes this board, it must not be something that can be done. So they've made a board with 2 EPYC slots on it, but you're not meant to do that. They just still sell it. It's like a $600 board. So what we finally did is we ordered a single CPU board from a different provider. So we can, I mean, we've even sent the CPUs into AMD for them to test the CPUs. We still have a machine that doesn't work. It's hilarious. Yeah.
Did you guys end up switching out the case?
We switched out everything. There's not one part that we haven't done a different thing. And if you tell me there's like some jumper on a Supermicro board, it's like, oh yeah, there's a jumper in the bottom right. You just turn that over to this, it'll work.
It might seem odd, but I know it's the case with some boards that have double sides. Have you tried putting one CPU in and leaving the other one?
Oh yeah.
Okay.
I mean, it's worthwhile to ask things like that, but I would be shocked if we haven't tried everything. We've probably sat with this machine for 100 hours.
We got all the parts back in like July, wasn't it?
Yeah, it's really ridiculous. So I'm hoping that this motherboard we tried today will work for a single CPU, and then we'll just build 2 separate computers. Well, I mean, we'll have to get a separate board and another case and another power supply.
Okay.
So that's going to add, $1,000 to the build to have it in 2 machines instead of 1.
It's almost the price of that.
Huh? $8,000.
Jeez.
Almost the price of that.
Because I know that you told me you pre-order stuff and those
Yeah, so
are 20.
it is all on my credit card. What's this? That's the way it goes. All right, so variable resolution takes time. That's overhead, that it takes time. So when we're inside of a Java program here, and oh, I opened it again. That's good.
You try cracking the motherboard in half. That way you can have instead of buying a new one.
We did think that we had shorted out the original motherboard because it was in the case and it might have been hitting something. So now we're building it completely out. I mean, it's not touching metal. We're building this thing on top of cardboard boxes at this point. So if it turns on, like that makes no guarantee that we can get this thing into a case and have it work. But at least we get that initial, and the motherboard doesn't even beep. There's a light comes on. It's like, oh look, you're getting power to it. Just messing with us.
There was someone in WIT last year that built his computer in a wood box. That was Brad.
Yeah. At least he doesn't have to worry about shorting it out. And actually, it's got to get really, really hot before it catches fire.
Did you ever get the M.2 back?
No, we're actually missing. We're missing an M.2 solid state drive too. So we actually have less parts now than we started with.
But you mean it like it just
It did. I thought that I accidentally sent it back with one of the motherboards we returned.
Oh, yeah, I remember.
But I asked them and they said no, but I don't trust that. But what are you supposed to do?
Right.
So.
Because you guys nobody walked off it because that would have been caught on the camera.
One would presume. I don't think we checked, but
No. Oh,
if that's the one fall guy, this whole thing, yeah, I think life will go on. All right. So as Java is looking at this, as the compiler is looking through this, and the Java runtime environment is looking at this, it's going to come to this A and say, what kind of animal is this? Is it a int? Is it a number type? No. Is it a char type? No, because no single quotes. Is it a Boolean type or a reserved word? No. Is it a string type? No double quotes. So it must be a variable type. If it's a variable type, it then goes into variable resolution mode, which takes time. It's going to have to go and talk to the Java virtual machine and say, please give me the value for this variable name. Java will then come back and say whether or not that variable name is in the current scope, like as in, has it heard of this variable before? Assuming the answer is yes, it'll have to go and look it up, follow the yellow brick road through memory until it gets to the place in memory where, in this case, our 5 actually is stored. So somewhere in our computer's memory, there actually is this value 5 stored somewhere. All right, and we use A, so somewhere there's this little lookup table, similar to like Unicode or ASCII, where we have to look it up and say, if I have a variable name A, where in memory can I go and find this guy? Okay, and it says, it's that memory address, blah, 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 some crazy hexadecimal value. Okay, so then you follow it to that memory address, you get your 5 comes back, gets delivered to the Java runtime environment, spits out to the screen. So at runtime, this A gets replaced with a 5. That's variable resolution. But that took time to resolve that variable name to its containing value. Make sense? Now, that doesn't mean don't use variables. That just means that, you don't always have to store something in a variable. And that's kind of an important thing with programming is I think we get into the habit as programmers that whenever we have a value, you always have to throw it into a variable before you can use it. Now, maybe often you put it into a variable if you're going to use it more than once. But let's say you needed the value for pi, 3.14, you take it out farther, 1.159, whatever. Let's say you needed the value for pi, and you're only going to use it one time in your entire program. It would actually be faster for you to hard code the value in that one time. Okay? Now, pi is built into the language. Is that what you're going to ask? Yeah, it's math.pi. But assuming you didn't know that it was built into the language, 2 seconds, you got a 3.14159 typed in there, and life goes on. Right? We're good. And I don't know how many decimal places it goes out to in math.pi, but it maybe goes as far as a double will support. But whatever. If you're in a situation where the number of significant digits is really, really, really important, you're probably a fairly advanced programmer at that point, and you will come up with some sort of linked list solution that we'll learn about in the next class, where you have calculated pi to the 25,000th significant digit or something like that, and then your numbers are still slightly off. What's the Chuck Norris joke that he knows the last digit in pi? Isn't that the? Yeah, Chuck Norris knows the last digit in pi, but pi is a repeating, right? Not a repeating number; it's an infinite number, right? Yeah, but he knows the last digit.
Exactly.
Or another one was his phone number is what, the last 7 digits of pi? Something like that. That's another. That's another one. So the same joke, just a little bit twist on it. Okay, so we understand variable resolution and kind of how that works. Takes time. No different here than it was in Python in terms of when you have a variable, it has to go and look up the value. Okay. Difference with Java versus Python is we are dealing with a strongly typed language. So when we define A, it is a container in memory that is specifically being flagged to hold one of these dudes. Hold an int. Okay, so if 2 seconds later I say, oh, I'm going to put the character C in there. Notice it's okay with that. I'm going to print this out. What do you think is going to print? Let's start off with this. Why is it okay with this? As opposed to not okay with that, right? Go ahead.
Because A was declared as an integer above it.
Right, A is declared as an integer above it, so it makes sense that it can't hold a string, but why can it hold a char? Go ahead.
Since it's a primitive object.
Okay. So that means I should be able to hold a true in there. So not just because it's a primitive type.
Isn't it true a Boolean expression?
Well, yeah, but so his argument was that it was allowed because my this guy is a primitive type, where a string was not a primitive type. A string is an object type. So I showed another primitive type that wouldn't fit in there. Go ahead.
It's something like hex code, but it's taking
I don't know what you mean by the hex code part of that, but the number side of things makes a whole lot of sense to me. If we flip back here real quick and I go to, what slide is it? This one? What's a char? It's a number. It's a number. So what do I put? So int A rather, so A is a variable capable of holding a number, a whole number. I put a whole number in there right here, and I put a whole number in there right here. Just because it looks like the char C to us, this guy is a number. That's a reverse Unicode lookup. C is going to get looked up on the Unicode table and get a value associated with it, and that's what we're sticking in A. What's going to print out here when I display the contents of A? Because this variable is still going to resolve, right?
Yeah.
It's going to turn into the value that A holds. And what value does A hold?
char C.
Try again. Depends on how you're thinking about that, whether you're actually wrong or not.
Doesn't hold the value of 5. No, it doesn't.
It held the value of 5 before, then I immediately changed it to hold that.
The char C.
But what's actually being stored in A? Okay, Y is 63. So he's tested the code already, he got a 63.
Oh.
Now explain why.
Oh, no, I just listed up.
Oh, well, tell me why then.
It's the Unicode value. It does. Okay.
The computer doesn't know anything about this. The computer's going to say, this is a char type, because I have the single quotes around it. What do I do with char types? I got to go to the Unicode table. It's going to look up the numeric value of that, which you said was a 63. And it's going to store, so this guy becomes a 63. And it's going to store the 63 in A. Is 63 something we're allowed to store inside of a bucket capable of holding an int? Absolutely is. So if I go and run this, you must have been looking up a uppercase.
Yeah.
See? Yeah, it's a 99. So 99 is the lowercase c on the Unicode table. Now, if I want to see, pun intended, if I want to see that c, when A gets resolved, it'll get resolved to the integer that lives within it, because A is an int. I can then do something called typecasting, and I can say, treat whatever value this guy is as a char. And then when I hit play, it'll convert that back to a C. Okay, now just to show you kind of what's going on there, we saw a 99 as a C, which means a 98 should be a B. The char version of 98 is a B. So I'm forcing this number to be treated as a char. This is called typecasting. Something we're not going to do very much, at least not for a while, but just kind of showing almost a trivia thing. All right, so you can turn a value into another value, assuming it makes sense. Like you probably can't convert a 98 to a Boolean because Java's not going to know what the heck you mean. But as long as it makes some sense what you're doing the conversion between, if it's mathy types, then it should work. All right, that makes some sense? Okay, so this was allowed, but it was allowed for a reason that wasn't necessarily immediately apparent to all of us. And that's really an important aspect with programming is when you look at something, it kind of goes back to the whole don't judge a book by its cover type thing. Don't immediately come to a conclusion about what you're looking at before you've thought through the process of how Java or whatever language you're working with will resolve that value. Okay. This guy here, even though all day long to a human, if somebody asks you, what is that? You're going to say, that's the character C. That's the character C. That's the character C. If we spend a little bit of time thinking about it, we say, that's going to be the numeric value from the Unicode table that maps to the character C. Now I have a number, and a number can get stored in A because A is capable of holding numbers. Make sense? Now, I'm not encouraging you to do something like this. This is more of a, almost like a trick question type thing. So on an exam or something like that, I would not, if I was asking this very specific type thing, I could ask something like this. But I wouldn't, like in the middle of some code example, throw you like a, like a trick shot like this, and all of a sudden you get the wrong answer because of this stupid trick in the middle of it. I wouldn't do that on an exam unless I was testing this exact, like here's 3 lines, what will the output be? Does that make sense? Mm-hmm. All right. So questions about variable resolution. Makes pretty good sense. Takes a little bit of time. We don't care about that. But what's important for us is when Java sees something like this, it has to determine what kind of dude is that. Same thing happened with Python. Even though it was a loosely typed language, it still had something called a type inference engine. We didn't tell it what kind of type it is, but I guarantee every variable held a type. Okay, so at runtime, Python had to figure out what kind of thing lives inside of that variable. Okay, so Java goes through that process. Is this a number? No. Is it a char? No. Is it a string? No. Is it a reserved word? No. Must be a variable. Go and ask the Java virtual machine to look it up for us. Make sense? Questions, comments, concerns, bribes? All right, next class, I'm going to call it a high likelihood of Hello World quiz. So look at Slack, get that, get Eclipse opened up, type in Hello World multiple times, do it from memory. You should be able to write an error-free Hello World program next class. No partial credit on that one. So it's either perfect or it's a 0. Well, if you're in class, the lowest I give you on a quiz is a 30. So it's a perfect or it's a 30. So you might want to come to the ice cream social. All right, I will see everybody on Thursday.
What do you?